Welcome to the world of electronics. Electronics are everywhere. From the smartphone in your pocket to the microwave in your kitchen, electronics power our modern world. Look around you right now. How many electronic devices can you see? These devices seem complex, but they all work on simple principles that anyone can understand. This beginner's guide will introduce you to the fascinating world of electronics. We'll explore the basic building blocks of electronic circuits, resistors, capacitors, and transistors. You'll learn how these components work together to control the flow of electricity and perform useful tasks. Understanding electronics can open up a world of possibilities. You can learn to repair electronic devices, build your own gadgets, or even pursue a career in this exciting field. This guide will provide you with the foundational knowledge you need to embark on your electronics journey. So let's dive in and explore the amazing world of electronics. Imagine a garden hose with water flowing through it. Now imagine squeezing the hose. The water flow decreases, right? That's what a resistor does in an electronic circuit. It resists the flow of electricity. Resistors are like the traffic controllers of electronics. They are passive components, meaning they don't produce or amplify energy, but they play a crucial role in managing it. Resistors are used to limit current, divide voltages, and adjust signal levels. The resistance of a resistor is measured in ohms. A higher resistance means more opposition to the flow of current. Resistors come in various shapes, sizes, and resistance values to suit different applications. Next time you hold a remote control or turn on a lamp, remember the resistors working silently inside, ensuring the right amount of current flows to power these devices. Imagine a water tank that stores water for later use. That's what a capacitor does with electricity. It stores electrical energy for later use. Capacitors are like tiny energy reservoirs within electronic circuits. They consist of two conductive plates separated by a non-conductive material called a dielectric. When voltage is applied across a capacitor, it charges up and stores electrical energy. The amount of energy a capacitor can store is called its capacitance, measured in farads. Capacitors are used in various applications like smoothing out voltage fluctuations, filtering signals, and storing energy in flash memory. Think of a camera flash. The sudden burst of light is powered by a capacitor that releases its stored energy rapidly. Without capacitors, many electronic devices wouldn't function as intended. Imagine a switch that you can control with a small amount of effort. That's what a transistor does in an electronic circuit. It acts as an electronic switch controlling the flow of current. Transistors are active components, meaning they can amplify or switch electronic signals. They have three terminals: base, collector, and emitter. By applying a small current to the base, you can control a much larger current flowing between the collector and emitter. Transistors are the brains behind computers, smartphones, and countless other electronic devices. They are used to amplify signals, create digital logic gates, and perform various other functions that make our electronic world possible. Think of a transistor as a tiny gatekeeper, directing the flow of electricity based on the signals it receives. They are essential components in modern electronics. Section 5 circuits, the heart of electronics. Imagine a network of roads connecting different cities. That's what a circuit is in electronics. It's a closed loop or pathway that allows electricity to flow and power electronic components. Circuits are like the nervous system of electronic devices. They provide the pathways for electrical signals to travel and perform specific tasks. Circuits can be simple, consisting of just a few components, or complex, involving thousands of components interconnected on a circuit board. A basic circuit typically includes a power source, like a battery, conductors, like wires, and one or more components that perform specific functions, such as resistors, capacitors, and transistors. Understanding how circuits work is essential for anyone interested in electronics. It's like knowing the language of electronics, allowing you to read and understand electronic schematics and build your own circuits. Section 6. Ohm's law, the relationship between voltage, current, and resistance. Imagine a water pipe. The water pressure is like voltage, the amount of water flowing is like current, and the pipe's size is like resistance. Ohm's law describes the relationship between these three fundamental electrical quantities. Ohm's law states that the current, or I, flowing through a conductor is directly proportional to the voltage, or V, applied across its ends and inversely proportional to the conductor's resistance, or R. Mathematically, this can be expressed as I equals V divided by R. This simple equation is fundamental to understanding and analyzing electronic circuits. It allows us to calculate the current flowing through a circuit, the voltage drop across a component, or the resistance required for a specific application. Understanding Ohm's law is like having a key to unlock the secrets of electronic circuits. It's a fundamental concept that will serve you well as you delve deeper into the world of electronics. Section 7. Safety First. Handling electronics responsibly. Working with electronics can be fun and rewarding, but it's crucial to prioritize safety. Electricity can be dangerous if not handled properly. Always follow these safety tips when working with electronics. Never work on energized circuits. Always disconnect the power source before touching any electronic components. Use insulated tools. When working with live circuits, use insulated tools like pliers and screwdrivers to prevent electric shocks. Wear safety glasses. Protect your eyes from flying debris when soldering or working with components that can shatter. Avoid touching components. Some electronic components can get very hot during operation. Avoid touching them directly to prevent burns. Store components properly. Store electronic components in a cool, dry place to prevent damage from moisture or static electricity. Dispose of batteries responsibly. Batteries contain hazardous materials. Dispose of them properly according to local regulations. Remember, safety should always be your top priority when working with electronics. By following these simple tips, you can enjoy exploring the world of electronics safely and responsibly. Section 8. Simple electronics projects for beginners. Now that you have a basic understanding of electronics, why not put your knowledge into practice? Here are a few simple electronics projects for beginners. Build a simple LED circuit. Learn how to connect an LED to a battery and resistor to create a simple circuit that lights up. Create a touch-sensitive switch. Experiment with a touch sensor and a transistor to build a circuit that responds to your touch. Assemble a basic alarm circuit. Combine a buzzer, a switch, and a few other components to create a simple alarm system. These are just a few ideas to get you started. Numerous online resources and books offer a wide variety of beginner-friendly electronics projects. Building simple electronics projects is a great way to solidify your understanding of electronics concepts and gain practical experience. Start with small, manageable projects and gradually work your way up to more challenging ones. Section 9. Conclusion: your journey into electronics. Congratulations! You've taken the first step on your exciting journey into the world of electronics. You've learned about the basic building blocks of electronic circuits, resistors, capacitors, and transistors. You've explored the fundamental concepts of circuits and Ohm's law, and you've learned about the importance of safety when working with electronics. This is just the beginning. The world of electronics is vast and constantly evolving. There's always something new to learn and discover. Continue exploring, experimenting, and building your knowledge and skills. Remember, the best way to learn electronics is by doing. So, gather your tools, find some simple projects, and start building. You might be surprised at what you can create. Welcome to the fascinating world of electronics. Let the journey begin.